Hello amigos, welcome to CP Addict. In this video we are going to explain today's problem from the August LeetCoding challenge, and it is called largest component size by common factor. So what it says is we have a non-empty array consisting of unique positive integers, and there are a dot length nodes, and we have an edge between any two nodes if they share a common factor greater than 1, or we can say if they have any common prime factor, then there would be an edge between those two nodes, and the node values are ai and aj. We need to return the size of the largest connected component in the graph. For this example, we see that 4 and 6 has 2 as their common factor, 6 and 15 has 3, and 15 and 35 has 5. So all of them are connected with each other. It also follows the transitivity relationship. Okay, then the answer is 4 in example 1. In example 2, only 20 and 50 share a common factor, which can be 2, and 9 and 63 share the common factor, which is 3, but these two do not share any common factor with 9 and 63. So the maximum size of any component is 2. In this case it is 8 is this case, and these are the constants. Now let's see how we can solve this problem. Now I would be solving not I solved this problem using disjoint set union. Let me just first write down few key data structures and variables which I used for my solution. The first one is all factors. It is a set which contains all the prime factors observed or found till that point. Okay, it is a set. And the second one which I used is fact id. Yes, in this joint set, first of all I created n. First of all we would be having n sets, as we have n nodes in our graph. So we have converted into a graph. For n elements we have n nodes, and every node has a unique id associated with it. So fact id is a map which tells me we have a factor there, and it tells me the node id it belongs to. So yes, let me also tell you one more thing. In each of the node, suppose I have a node in disjoint set. This is a one disjoint set. In this I am maintaining factors, prime factors which belong to this set, and also I am maintaining another value which is size, which tells me the size of this disjoint set, that is the number of nodes in that disjoint set. Initially the size is 1 for all the sets. So we have size there, and we have prime factors. So this, for any particular factor, it tells me the the set id it belongs to. And yes, I have just mentioned size. It tells me the size of any disjoint set. It is also a map. So for any id, that is the id of any disjoint set, it will return the size of that disjoint set. So, and what else I used? And yes, I also used one parent. Parent I tells me what is the parent of this node, because in disjoint set we assign parents to every node. Like structure is something like this. We have one node which represents the whole disjoint set, and all other disjoint sets are descendants or children of this particular node. Okay, so parent of this node is this, the parent of this is and this one, and suppose we have another node down here, then the parent of this is this node, the node 1. So yes, I am maintaining a parent I, and initially for any node parent I is equal to y, as initially we have a disjoint set of size 1. So we just have one node in our disjoint set initially. Now let's see what we can do to solve this problem. Yeah, so I have mentioned, suppose this is one disjoint set. I am maintaining a list of factors which belongs to this disjoint set. Let's say those are f1, f2, f3. These are the factors, and I also have a size here which tells me the size of this disjoint set, and I have ID of this disjoint set. And suppose I have another disjoint set, it has its separate ID. Let's say it is ID1 and ID2, it is size 1 and it is size 2, and it also have some factors, let's say f4 and f5. Now if I find out any new disjoint set, let's say it has ID 3 but it has factors f4 and f1. Now I see that f1 is present in both of these disjoint sets, so it means that there must be some number which is present in this disjoint set. By number I mean some node, because we can have multiple nodes in one disjoint set which has a factor f1, and also in this particular disjoint set we are having some node which is having f1 as its prime factor. So there should be an edge between those two nodes, and if we connect those two nodes, it also means we are in a way connecting or merging these two disjoint sets. Then after when we see that we have a common prime factor in these two disjoint sets, we would be merging these two disjoint sets, and I would be updating this size 3 is equal to 1, which is the size of this like not 1, let's say size 3, which is the size of this disjoint set, is equal to size 3 plus size 1, because now I have merged this earlier the disjoint set 1 node the set to this. Size has increased and I'm updating its parent. Now parent of this 1 is equal to 3. Now this set is a descendant of this set, so I updated my parent and I updated size. These two things I'm doing in the union operation. This is called union. And also I'm also seeing that f4 is also present in set 3 as well as set 2, so I also need to merge these two sets. So now after merging, I would be updating my size 3 is equal to size 3 plus size 2. Also parent of 2 is equal to 3, because now this one is a descendant of this. So we will keep on doing we would be continuously doing this process, and at the end we would be finding out the maximum size of any disjoint set. Because if we I think that's all for the explanation part. Yes, there is one more thing. In my solution I used C function. It is used to find out the prime factors of any num in log n time. Well, there is I will be sharing the link link of some blog where you can learn about. If you do not know about this C function, I will be sharing a link in the description box where you can learn about this C function. And for any to find out the prime factor of any number, it will take log n time, but it also have some pre-computation, and that pre-computation will require n into log of log n time. So as far as our constraints are concerned, this will not cause any problem to our solution. So I have used this thing. It will return, it can be used to find out the all the prime factors of any number. Okay, I hope you have got my approach. I think, do not, if I see that I need to explain anything else during my code explanation, I will come back to this diagram. So let's see the code now. Yep, this is the max set size which I would be returning at last at the end, and this is the C function, which is the pre-computation which I was talking about. The C function, I won't be explaining how it works. I would be sharing the link. The time is n into log n, and this get factorization, what it does is it returns a set which contains all the distinct prime factors of integer x. So I would be using this function. This is all for these two functions. Yep. So now in my for loop, I'm going through all the elements. First of all, I'm finding out all the distinct prime factors of this current element of AI, that is, it will take log n time. Now initially I'm the size of this disjoint set is 1, as at this point it only contains itself, and also the parent of this node is itself, like it is itself its parent. Okay, as initially we have only one node in our disjoint set. Now for current factors, current factor stores all the prime factors of AI. I'm seeing, yeah, all factors. Yeah, I mentioned about all factors. All factors contains the prime factors which I have seen till this point. Like suppose if right now I am at index I, then all the prime factors which I have seen from 0 to index I minus 1, all the distinct prime factors would be there in all factors. So if I see that I have already seen this prime factor, which is also a factor of this current number, it means I have some disjoint set which contains this number. Okay, so it also must have some array element as well, which is having the same prime factor which I am seeing in AI. So then I need to merge the current disjoint set with the previous one, as I explained in this diagram. For suppose I am adding this disjoint set at this moment. So I've seen F1 is already present here. So what I need to do, I need to merge it one by one. I am going through these factors of my new disjoint set, and if a factor is already present in some other disjoint set, then I need to merge them. Otherwise I'll just go on with my process. Yeah, and I'm seeing if what is the parent of that disjoint set, that is the parent of this, which is already having that factor. I'm seeing if the parent is not equal to I, that is, if it does not points to this current node, then I'm changing its pointer. And then I went to union, and in union I'm increasing the size of my current disjoint set and changing the parent of the older disjoint set to the new disjoint set. Yep, this is for union part. And now I'm changing the fact ID, that is the current factor belongs to disjoint set which is having ID as I, and I'm adding this current factor to all factors, as right now I've seen this factor which is x, so I'm adding it to all factor. And after doing all this, in each of the iteration I'm seeing if the size of the current disjoint set is the largest one, I'm taking the maximum out of it. At the end I'm returning its answer. So yep, that's all for this problem. I think for to solve this problem you should be having knowledge about you should know about disjoint set unions and how it works, what are the key properties and key methods which are involved in disjoint set union. Okay, and yep, take care and sayonara. Yep, I'm not going at this moment. So if you like our videos, then please do subscribe, as around 85% of our viewers are not subscribed to our channel. Yep, this is the moment where I say goodbye.